Thank you so much for being here. I'm Kimberly Collins. I'm the director of the Leonard Transportation Center, and we're very happy to have you all here today. I know we have a number of people who are still joining us, but I think we'll get started. So today we're going to have a great discussion about hydrogen and the emergence of hydrogen as another sort of tool within our toolbox of finding a cleaner, better transportation system for our future. I'd like to, before we go through any of what our day will look like, invite the new dean of the Jack H. Brown College of Business and Public Administration, Dr. Tomas Gomez Arias, to say a few words.
Thank you, Kimberly, and it's a pleasure to welcome you all on behalf of California State University San Bernardino and the Jack H. Brown College of Business and Public Administration to this dialogue series that the Leonard Transportation Center has been organizing for. We were talking about that a minute earlier, whether it was 5, 6, 7 years. Today, we are talking about, as you were mentioning, hydrogen and cleaner technologies preparing for the future. And I'm really looking forward to hearing what this fantastic panel has prepared for us and learn more about how hydrogen can be part of the solution for cleaner air, cleaner tomorrow, a healthier community. I want to say a few names. I want to appreciate the work of people who have put this together. This doesn't happen out of thin air. There are people behind the screen who have worked at this. In addition to Professor Kimberly Collins from the center, Greg Hulsier and Kerry Witt from HNTB, Doran J. Barnes and Josh Landis from Foothill Transit, Erin Rogers from Omnitrans, and Berchman Melancon from San Bernardino Valley College, who were part of the planning committee for this event. And I also want to thank our sponsors, the organizations that are supporting the center and this series and making it possible. San Bernardino International Airport among our platinum sponsors, Mike Burrows there, thank you. HNTB Corporation, Greg Hulsier, who is HNTB Vice President, and Kerry Witt, who is also a Vice President there, and the Ontario International Airport. Thank you all for your platinum sponsorship. Our gold sponsors are Woodruff, Pryden and Smart, Metrolink, SCAG, and SoCalGas. And our silver sponsors are Advanced Civil Technologies, EXP, Foothill Transit, GLA, Guida Surveying, Lane Construction, Omnitrans, and PPM Group. Thank you all for making this happen. Thank you for your support. I'm looking forward to hearing the conversation today. It's important, it's relevant, and it's part of building the future we want to for our community and for our planet. And with that, Kimberly, I pass the baton back to you.
Thank you so much, Dean, for joining us today and that really warm welcome. Now I'd like to invite up really a great partner within this dialogue series for the past 5 years. And with that, all that list of those who have been our sponsors, we are thinking about year 6 coming up. So if you're interested in your organization's interested in sponsorship, or even if you have any ideas on topics you'd like to hear us bring forward, please let us know, because we're in that planning phase right now. And Greg can tell you, as his welcome, of one of the founders of this series, Greg Hulsizer from HNTB.
Thank you, Kimberly. Yeah, this is exciting. I understand we have more than 100 people that signed up for today, which is, I think, our largest ever. And the reach that this program now has and has had, and the depth of the discussion and the quality of the content, it just amazes me every time. As we look forward to next year, I'm super excited because you think, how many more topics can we cover? We recently went over the list of topics, and it's been quite broad and far-reaching. But I know there's going to be some new areas that we can discuss. So as Kimberly said, if you have topics that you think would be great for us to cover, please let us know. So just on behalf of 5,000 of my colleagues at HNTB across the country, I want to welcome you all today. We're excited to have you participate with us. Last week, we got an opportunity to hear our Caltrans director and the California State Transportation Agency talk about the priorities for the state. They talked about safety, they talked about equity, they talked about sustainability, and they talked about the economy. This clearly fits right in the middle of the sustainability. So I'm really excited about today's topic. And I want to thank also Rafi and Estefania too. They help so much in between meetings and just do a lot of the legwork to make this happen. So thank you so very much. And I thought that I would just leave us with a hydrogen joke, which I didn't know they had them, but I came across one, and that is that if H2O is water and H2O2 is hydrogen peroxide, what is H2O for? Drinking, of course. So anyway, with that bad joke, I'll turn it back over to Kimberly.
Thank you, Greg. Thank you very much for that. That was a wonderful way to start off our so our day today, we're going to have 4 great speakers. So it's a really full panel, but it was we wanted to provide different perspectives from each of the sectors that we have. So we're going to start off, and we'll send out, it's in your mailing that we sent as well on the invitation to join the meeting. But we'll start with a poll in just a moment, and then we'll begin with Tim Sassine, who is the Director in Market Development and Public Affairs for North America. I don't know why your company is not there, Tim, but it's Ballard Fuel Cells. And then we'll have Al Burgunder, who's the Director of Clean Air Hydrogen Business Lead for Linde. And then we'll have Matt Gregori, who's the Clean Energy Technology Scout for Southern California Gas. And then we'll finish up with a practical sort of applied conversation with Roland Cordero, who's the Director of Maintenance and Vehicle Technology at Omnitrans. So we're starting with sort of this large view and then moving our way down, and we'll have poll questions in between each of these so that we can, again, bring in your voices to this. We're hoping that this is really a conversation. It's a dialogue, as we call it. So we want folks to be able to discuss these important issues that we're confronting around our transportation system in the Inland Empire and nationally or statewide, and what it means for us. So with that, we'll start with our first poll. How knowledgeable are you on hydrogen's capacity and how it works? So very knowledgeable, knowledgeable, in the middle, unknowledgeable, or very unknowledgeable. We'll just take a minute here to look at this. So we have in the middle, unknowledgeable, about 23%, in the middle, about 55%, knowledgeable, 9%, and very knowledgeable, only at 9% as well. So hold on one second, I'll share the results with you. And so we see that there is, again, I think I'm in the middle as well. I know just enough to be dangerous, but not enough to really be able to answer the questions that need to be answered. So with that, I am going to invite up our first speaker, Tim Sassine from Ballard.
My name is Tim Sassine. I'm the Director of Market Development and Public Relations for Ballard Power Systems for North America. And I'm going to give you an overview of hydrogen and fuel cells and what we're doing in the market today, all the activity with hydrogen deployments, particularly transportation, a little bit about stationary. I got a lot of slides. I'm going to go fast. So if you see something interesting, please save it for the Q&A. And I'm more than happy to dig deeper into any of this. So my apologies for going a little bit rapid, but there's a lot in this space to get a good feeling for. Ballard itself has been around for over 4 decades. We've got about 1,100 employees, a whole bunch of patents, and we're publicly traded. We've got a lot of buses. Buses are very much in our DNA. Also trucks, more and more, trains, ships, and stationary power. I'll talk about that, but suffice it to say, we've got hundreds of megawatts, approaching a gigawatt of fuel cell products delivered, and lots of field experience. So we've been deploying products on the road for over 25 years, particularly in California, but all over the nation. And it's growing rapidly. The fundamentals of a fuel cell, this is what it looks like. I apologize for those of you who may already be familiar, but basically what we're doing in a fuel cell is, instead of burning hydrogen, we're reacting it at a low temperature. Same end effect, but without the externalities. So this top picture shows on the left side, part of this sandwich, one of the bipolar plates. There's another plate on the right side. On the left side, you see the hydrogen coming in through flow channels in that plate. It'll come up against the membrane. The proton will migrate its way across the membrane, and the electron will go through your electrical circuit. They meet up on the other side with oxygen from the air, create water, and the whole process creates heat as well. We call that a unit cell. So you're creating heat and electricity from reacting hydrogen with oxygen and getting water as a byproduct. There's what it looks like incarnated. At Ballard, we use carbon plates. Some people use metal plates, but they will look about the same. A plate on each side and a membrane in the middle. That membrane has the magic bits like the platinum catalyst, gas diffusion layers, seals, things like that. That cell will make about 1 volt, and we'll stack those up to get the voltage we want, much the same way you would do with battery cells. You add up battery cells to get the voltage you want, and then you parallel those things to get the power you want. In the case of fuel cells, we parallel up fuel cell stacks. We put them into a module. This is our FC Move module shown here. And in that module will be care and feeding of that stack, like the compressor to blow in and humidify that air and recirculate the hydrogen, and then monitoring and cooling as well. And that is the box we make, and that's the box that goes into your vehicle, in the engine bay, in the place where an engine would have gone. This is how it looks on a European bus. They have a little bit different layout, but what's nice is you can see the parts and pieces. You see the storage tanks up on top. These look like natural gas storage tanks. That's the same on the North American buses, the high voltage batteries as well. We hybridize with batteries for the sake of collecting braking energy, but the battery packs are much smaller, something like 50 to 100 kilowatt hours. Air conditioning, of course, electrified on top. And this, you can see the fuel cell module in Europe. We have smaller fuel cell modules, 70 kilowatts. You can see that here. We'll be going with 100 kilowatts in the US. Right now, we have 85 kilowatt modules on the road. But this is basically the layout. Fuel cell module, batteries, fuel storage, and power electronics to marry it all together. This is an electric bus, but you take out most of the batteries and you put in a fuel cell and fuel storage. We've got over 1,300 buses on the road now, powered by Ballard, and lots of miles and kilometers behind us. Buses with demonstrated over 30,000 hours of fuel cell stack life. And not just ours, some of the older buses that AC Transit has been running have gotten over 30,000 hours as well. It really shows that the technology is capable of lifetimes that are enjoyed by present combustion engines. This is how we're deploying across the US. This is expanding now with the latest federal low-no grants. Of course, we've got a whole bunch of deployments in California. We've got a couple of deployments starting up in Nevada, also Champaign-Urbana in Illinois, and a couple of other low-no winners there. Michigan expanding its fleet, SARTA in Canton, Ohio expanding its fleet, Comet in South Carolina about to start its. We're hoping for a win in New York. Lots of interest in Florida and Texas, and also in Washington and Oregon. This is not a red state, blue state thing. This is really decarbonization, electrification across the US for whatever means is most appropriate for that region. And that's one of the magic qualities of hydrogen. Here's how the numbers break down. We'll be approaching 100 buses. I think we have 100 buses on the road now in North America, with a whole bunch on the way, well over 60. Thank you to Roland for pushing those numbers as well. And in Europe, we're exceeding this. We're probably over 200 now. I think we're just at 200. Big orders such as Birmingham with 100 buses, Cologne for over 100 buses, and then Asia, lots of activity over there as well. Costs have come down a lot. Even looking back to 2019, we were within 11% of the nearest comparable battery bus from Proterra. And if you looked at a 12-year warranty price, we were within 2%. Looking way back to 2010 and coming down, we've cut from over $2 million to approaching $1 million a bus. Like I said, really close to those battery prices. And both technologies need to come down and will come down in price, but we've been very aggressive and very successful in our cost out. And we're anticipating 70% cost out of the fuel cell modules by the end of this decade. And we've got a lot of good reasons to believe in that. In fact, a lot of people are looking at total cost of ownership becoming superior for fuel cell electric vehicles over diesels even before the end of the decade. This is looking at studies from McKinsey and Deloitte and others. And mostly this is through the cheapness of the powertrain. The powertrain itself doesn't have that many components. Once it's in mass production, it should be quite cheap, and anticipating reduced fuel costs. And we'll talk about that as well. Service costs have come way down as well. And there's some great reports to look at there. We're really showing comparable service costs to compressed natural gas buses, and that's with limited deployment and limited technicians out there. So we expect a lot of advancement there as well as we train more and more people to become proficient. AC Transit, this is from their second study. Check out their third study, also very interesting. They have 5 buses of 5 different technologies that they're comparing. They're taking data on. They're looking at cost per mile. The fuel cell buses now, these are 5 New Flyers. They have very comparable operating costs. In fact, in some ways superior to what they're seeing with diesel and diesel hybriding, and close to what battery is seeing as well, with the advantage of very rapid fuel times. And they're expanding their fueling facilities there and seeing these fills in under 10 minutes, well under 10 minutes, which is a huge operational advantage. And we see as fleet size goes up for battery electric buses, you go more and more into your grid, into your public utilities infrastructure, and costs go to transformers, to feeder upgrades, even substation upgrades as you get over 100 buses in a depot. On the fuel cell side, you actually have decreasing marginal costs as you add buses on. The components are quite oversized for small fleets, but as you get larger and larger fleets, you can add in buses for smaller and smaller costs. So as you have very large agencies, you'll see this curve really coming to fruition. We've had this notionally for a while, but from feasibility studies and recent installations, it really bears looking at. Infrastructure costs are a major reason to look at hydrogen and fuel cells. This is what a liquid fueling station looks like. This is at Orange County. They have about, I want to say 4,500 kilograms of liquid hydrogen here. And these are vaporizers in back. This facility, all contained within the bollards you see here, is capable of fueling 50 buses. They have 10 buses on that right now. Dispensers, delightfully uninteresting. They look just like a fueling dispenser. And in fact, you can put them right in line with the fueling that you do for diesel or for other buses. That's Orange County's setup. Regarding safety, there's lots to talk about for safety with hydrogen. We could go on and on. Most people know that it's a flammable gas, but a lot of people don't think about the fact that we deal with flammable materials every day. In fact, one of them that we deal with almost every single day is gasoline. Gasoline is nasty stuff. And when you compare hydrogen to gasoline, you see some real advantages. Not only is hydrogen non-toxic, but it also is very buoyant and very diffuse. When it gets out, it can be contained in how it's released, as shown in the study done by Ford, comparing 2 cars that are intentionally given a fuel leak and an ignition source. The gasoline you see pooling on the floor, creating vapors, engulfing the vehicle in flames, whereas the hydrogen can be contained to a single release point and safely evacuated. Comparing it to gasoline and diesel, there's so many personal safety advantages, particularly regarding toxicity and ingestion. Next time you go to fuel your car, notice how much gasoline you're smelling. If you drive a truck or a diesel, you'll really be familiar with that. All these different criteria, pollutants that come out that we're very familiar with. The thing that you have to bear in mind with hydrogen is flammable, and you need to treat it like a flammable gas, the same as you would with compressed natural gas. And converting facilities, you do essentially the same thing. You make sure you have gas detection sensors, ventilation in the roof, and also explosion-proof electrical fixtures above the roof line. One other thing that is worth mentioning is that with hydrogen and fuel cells, you separate out your energy storage into very strong tanks that are literally bulletproof, and they're isolated from where energy is flowing, where power is created. And that, if you're going to have a problem, it's going to be where the power conversion happens. With batteries, and we use batteries in our buses too, you pack both of those, the energy storage and the energy conversion, into one spot. And that's what battery manufacturers struggle with as they densify this technology. It's a challenge. And so did I get muted? Hopefully I've been talking for the last 15 minutes. Anyways, it's one advantage that you'll see with hydrogen and fuel cells, is that separation of energy from power conversion. In winter, it's true that we are around 50 to 60% efficient, but that is also heat that is used to heat the passenger compartment. Not only do we have extra energy on board, but also we have that heat that's used for combined heat and power for colder fleets. We haven't seen that so much in California, but certainly in Michigan and Ohio, and in our colder deployments in Europe as well. We're beyond buses, we're in trucks and trains and rail trucks. We've got a whole bunch of urban delivery trucks. We've done 2 years at the Port of Long Beach with Class 8. We've got a giant mining truck now getting deployed in South Africa. Lots of interest from the mining industry. We've got a couple of yard trucks, these yard dogs, out at the Port of LA at TreyPac, and 4 UPS trucks coming to West Sacramento soon. Some very big Class 8 trucks up in Alberta. Lots of activity in trucks. We're doing, as I said, yard trucks, Class 6 trucks with Hexagon Purus, as well as Class 8 as well. Huge amounts of activity in trucks. Again, the same story. We're seeing the technology have the capability of beating not only battery, but also diesel technology in the very near future. Trains, we have a train operating in China. We've got some getting on the rails in Europe and UK. We've got a project with CP Rail. It's gotten a lot of attention up in Canada. We have a switching locomotive that we're working on in California with Sierra Northern Railway. There are people working on a very interesting commuter train in San Bernardino. I'm sure we'll hear about that today. That's very exciting. Stadler's providing the train for that. Lots of interest in trains, lots of questions around fuel, which is common to marine. You have a lot of fuel to hold on board. People are looking at liquid or ammonia or methanol. Watch that sector. Lots of activity there. We're involved in about 6 projects in Europe and a large tugboat design study here in California. And we're looking at cold ironing. So some applications of stationary power, such as providing stationary power for ships at dock, is one of the areas that are already economically viable. I got a cool video here, but I'm taking up too much time, so I'm just going to keep moving forward. Stationary power, this is looking at the comparison of fuel cell power versus battery power for a data center for either 2 or 3 days, 2 or 4 days. And as you double the amount of time you need for fuel cells, you add an extra tank, whereas with batteries, you add a lot of real estate. We're bringing out our cost out from advanced manufacturing, a lot of what batteries have already done with continuous manufacturing. This is going to expand our production capability and drop our costs massively. When we talk about the fuel itself, you'll hear more about this later. You can choose between gas and liquid. One thing that you should bear in mind that critics of hydrogen say is that most hydrogen is produced from natural gas and fossil sources. That's true, but most of it is not used for transportation. Only a very small amount is used for transportation. More than that is made by zero emission hydrogen. Most of it's used for refining. So this actually is an opportunity, which hopefully will get hydrogen hub activities in. Bear in mind with electricity, it's the same case. Not all electricity is totally green. It depends on your source. And however that gets to you is the same for grid or hydrogen. It matters on where that carbon started with. Once it gets to your vehicle, you're zero emissions. There are schemes for using that refined hydrogen to instead use zero emission hydrogen, which then can be repurposed for trucks. That helps that economic transition. Again, too many slides for too short a time, but also bear in mind that recycling, lifetime emissions are important. How much embedded energy is in this technology, right? At Ballard and in the fuel cell industry, we recover that platinum. We get more than 95% of the platinum recovered. And when we look at a comparison in embedded energy, comparing 2 different buses, for example, we find that the fuel cell bus for embedded energy in those power storage and generation devices is about something like a third of what you would see from, or a quarter of what you would see from battery bus. Doing big cost out, this is our latest generation of fuel cell modules. And we also are working on low cost midlife replacement. You find real advantages there, and hydrogen hubs, bringing low cost hydrogen to you. The DOE wants to see $1 per kilogram production costs. Sale costs will be a little bit better, higher than that by the end of the decade. And we're waiting for that federal grant to come out with hydrogen hubs, over $9.5 billion that the Fed is investing, and looking to get $2 per kilogram hydrogen by 2026. That's the big picture. And thank you for your attention.
Thank you, Tim. That was quite the presentation. Lots of information. I don't know if there's any just sort of burning questions right now, or we can leave it to the end for our discussion if anyone has anything. If not, I will move on to our next poll question. But really, it was just asking if it's safe or not, and you've already answered that for us. It's as safe as any other fuel that's really out there. You have to treat it with caution, as you have to do with any energy source, really. And we need to think, proactively and really integratively to how do we bring hydrogen into our communities, and make sure that the infrastructure and the network is built out so that it can really be deployed across modes. I think that's our ultimate goal. So, and one thing I think you said, or another expert I was speaking to, is really thinking about the importance of, these larger projects, these public infrastructure projects, and what that means for the individual consumer down the line, as it becomes more integrated into our communities. All right, thank you. And with that, I will invite up our next speaker. Thank you again, Tim. Al Burgunder, who's the Director of Clean Hydrogen Business Lead at Linde. Al, thank you for joining us.
Okay, so let's just get started here. So Al Burgunder, Director of Clean Hydrogen with Linde. Linde is a global industrial gas company. We've been supplying hydrogen for well over 75, 80 years globally around the world. We have, as you can see here, we have a whole bunch of customers across the board. We are probably in terms of corporate organization, we're probably the largest globally. But in terms of hydrogen, we are supplying hydrogen and have been supplying hydrogen for the last 80 years, and doing it to support manufacturing, as Tim had noted, refining operations to take out sulfur from fuels and things of that nature. So we've been serving the world with hydrogen for a long time. Over the last 10 years, we've been focused on serving hydrogen for transportation, starting out with passenger vehicles, moving on to buses, and now we're heavily engaged with OEMs or truck manufacturers in terms of preparing for their rollout. Again, our role is primarily in terms of supplying the molecules. Tim did a great job in terms of talking about the technology in the vehicles themselves. Our view is we want to supply the molecules, and we want to supply the technology to make sure that the molecules can be fueled. As far as creating the molecules, there's multiple processes out there. We can take methane or natural gas, and we can reform that into hydrogen. Whoops. And so that's one method. Obviously, we have to deal with the CO2 that comes off that process, and that's an effort that is well underway. We have capture technology for that, and we're working with people that are heavily engaged in carbon sequestration. So using steam methane reformers or autothermal reformers to reform methane or natural gas is one way. Electrolysis production is another way, where you're using electricity and separating or reforming water into hydrogen and oxygen. And both products are useful in their own right. So obviously the hydrogen is going to be directed for mobility or for the other applications that Tim had highlighted in terms of stationary power, or in terms of manufacturing activities. One of the key factors is it's important to be able to condition your hydrogen. And we do that in a number of different ways. And one of the most prominent way is with liquid hydrogen. We actually take a hydrogen molecule and we cool it down to a very low temperature, about 20 degrees Kelvin, and we liquefy that product so that we can transport it. Now, the benefit of that is that we can transport a higher supply of hydrogen molecules, typically about 10 times versus conventional gas hydrogen trailers. And we can use it at very efficiently at fueling locations for, especially for the mobility market. We have a very large presence in North America regarding hydrogen. The yellow diamonds that you see on the map here are hydrogen liquefaction plants. As you can see, the closest one in the Inland Valley is over in Ontario, California. We produce over 30 tons, and we're just getting approval to add electrolysis technology to that site to produce more molecules. We also produce in La Porte, Texas, Alabama, up in the Chicago area, and Niagara Falls. Alabama has been the primary source to supply hydrogen as a rocket fuel for NASA and the Air Force. We also have pipeline distribution of hydrogen. And in many cases, we are actually supplying hydrogen from a plant that's right on a customer site. We call it an on-site production supply. Okay, so we have a map across the country. And as I said, the Inland Valley, we've been at Ontario since 1962, making liquid hydrogen and producing hydrogen at that site. And we continue to do that today, and we're expanding that with electrolysis. Globally, Linde is supporting the conversion of vehicles, mobility markets, to hydrogen. We are working around the world in China and Germany and Korea and Malaysia. We have facilities, we have technology, and we're supplying molecules to a variety of different fueling stations in California, and also involved in Birmingham, UK. So we're heavily involved in this space on a global basis. Tim had touched on the hydrogen hubs. This is a infrastructure funding program from the Department of Energy. It was put into law last year, and everybody is working to develop hydrogen hubs across the country. This is a wonderful opportunity to develop a supply solution that will serve a variety of different users. I talk to people about the fact that a hydrogen hub is similar to a shopping mall. You have a couple big players that you'll be supplying, but then you're going to have a whole bunch of other smaller shops, smaller organizations, transit agencies, and automobile suppliers, and trucking companies, and so forth, that you'll be supplying with this hydrogen hub. So this is a process that's underway. Proposals are probably going to go into the DOE beginning in the third or fourth quarter, probably the fourth quarter of this year, and funding will probably start next year. Thank you. So that's underway. The other thing I want to highlight here, and everybody has heard probably a good deal about that, and that is that President Biden has recently passed the Inflation Reduction Act. And that is going to be another funding source that helps reduce the cost of hydrogen and infrastructure that's being deployed across the United States. So the combination of the infrastructure bill and the Inflation Reduction Act, which is commonly referred to as a production tax credit, are two ways that are really going to help meet the goals that the DOE has set out in terms of the $2 per kilogram that Tim had presented earlier. Linde has been involved in this space for quite a long time. In this slide here, you can see our value chain. We're heavily involved in production, and we're using a variety of different sources to produce hydrogen molecules. We distribute the product in a variety of ways, whether it's liquid hydrogen, compressed gas hydrogen, or pipelines. Once it's at the use point, and Tim had presented a liquid hydrogen tank in one of the slides he did, We have pumping technology to get those molecules up to the preferred pressure that the vehicle manufacturer wants to have on board, whether it's 350 bar or 700 bar. And so we have that technology to do that. And we are, responding to the demands from a variety of different markets. And we're in the transit agency mode. We're in the rail. We have the first commuter rail operating on hydrogen in northern Germany. We're heavily involved in the OEMs as far as trucking is concerned. Also getting involved in marine activities and rail. So all those markets are opening up in terms of the use of hydrogen.
That's great. Thank you so much, Al. Again, lots of great information there about hydrogen. Next poll question. Thank you very much. So this one, how many colors of hydrogen are there? Simple one, it seems. So as we see, 57% said many. 23% said 3, and then we had 13% on 1 and 7% on 2. So Matt, I hope you're going to be able to help us further in understanding these next pieces of information around the hydrogen world.
Great, thanks, Kimberly. All right. Good morning, everyone. My name is Matt Grigori. I'm a technology development manager with SoCalGas's Research Development and Demonstration Team, or RD&D. Very excited to be here. And I will start things off coming off of that poll. And maybe this is a controversial stance to take, but I do not support or believe in the hydrogen rainbow. I think it's confusing. I think it covers up a lot of the details that go into hydrogen. It creates biases, and there are too many colors. There are just too many colors. There's so many ways to make hydrogen that every day I feel like there's a new one. There's chartreuse, and then there's eggplant and mauve. It's just too confusing. So I support the California Air Resources Board and their use of carbon intensity when I think about when we try to think about what's good hydrogen, what's bad hydrogen. So there will be plenty of opportunity, I think, at the end of the session for you to fight me on that. And I look forward to it. So first, I want to share a little bit of information about SoCalGas. It may be surprising to some folks that I'm here. I work for the natural gas utility. What do we have to do with hydrogen? So just to give you a little bit of background, SoCalGas has been around for over 100 years and is North America's largest gas distribution utility. We serve 22 million customers over 24,000 square miles in Southern California. Our mission is to build the cleanest, safest, and most innovative energy company in America. And we've committed to achieving net zero greenhouse gas emissions in our operations and delivery of energy by 2045. That's our Aspire 2045 commitment. And we think to achieve this goal, we can do so by supporting the development of clean fuels like hydrogen. You may have heard about our Angeles Link. We recently proposed to develop what would be the nation's largest green hydrogen energy infrastructure system to deliver clean, reliable energy to the LA region. The Angeles Link could support the integration of more renewable electricity sources like solar and wind, and would significantly reduce greenhouse gas emissions from electricity generation, industrial processes, heavy-duty trucking, and other hard-to-electrify sectors. So how would it work? We start off with 100% renewable electricity that is either on the grid, newly built, or currently being curtailed to provide power to an electrolyzer. Then we would use that electrolyzer to make green hydrogen. We've talked a little bit about fuel cells, but an electrolyzer is like a reverse fuel cell. So you put electricity in and you get hydrogen and oxygen out. We could then deliver that hydrogen via pipeline from areas outside of LA into the LA basin and deliver it to the industries and customers that need it the most. And we could use hydrogen to decarbonize hard to electrify sectors such as electricity generation, heavy duty transport, and industrial processes. We think that Angeles Link has the potential to displace 3 million gallons of diesel fuel per day. in LA, and that would reduce about 25,000 tons of NOx per year. This is a big project and it's still in the early stages of development, but it's just one of the ways that SoCalGas is working to achieve net zero greenhouse gas emissions by 2045. Now I'd like to talk a little bit about my program, Research, Development, and Demonstration, or RD&D. SoCalGas RD&D has been working on an array of technologies that could enable larger game-changing projects like Angeles Link. The RD&D program funds researchers to develop new technologies that we think will benefit our customers and all Californians through energy savings, reduced environmental impacts, and improved safety and energy reliability. Our program's divided into 5 research programs that span the entire energy delivery value chain. So starting off on the supply side, we have low carbon resources, which is focused on decarbonizing the gas supply. Looking at projects around producing hydrogen. As I mentioned, all those different pathways for producing hydrogen, we're looking at many of them, including electrolysis, steam methane reforming with carbon capture, distributed steam methane reforming, and some more advanced technologies like methane pyrolysis, which I'm really excited about. The gas operations program supports the innovation in pipeline transportation and storage operations. We recently held a webinar talking about a lot of the work in the gas operations program to enable the pipeline to accept blends of hydrogen. And then downstream of the gas system, we have my team, which is called Customer Solutions. We oversee technologies on clean power generation, customer end use applications, and of course, clean transportation. In 2021, RD&D spent $18 million on research to advance new technologies to help California meet its ambitious environmental goals. We achieved an average leverage ratio of 5.2x, meaning on average for every dollar that we provided to a research project, the project received $5.20 in funding from other agencies, utilities, or funding programs. And then this is the amazing RD&D team, staffed with experts in science, engineering, industrial process technology, and environmental policy. These are just a few of the universities, public agencies, research consortia, and national labs that RD&D has worked with in the past. We welcome the opportunity to collaborate with new research partners, especially those from diverse academic populations at universities and colleges that serve first-generation students, and students from environmental and social justice communities. So that was the primer on the RD&D program and SoCalGas, our interest in hydrogen. And so I'll talk a little bit specifically about the Clean Transportation RD&D program. This program focuses on minimizing the environmental impacts related to the transportation sector, particularly through the integration of hydrogen and renewable natural gas. In 2021, the Clean Transportation Program supported 29 research projects with technical guidance and about $2.8 million in funding. And we're just going to go through a couple of the highlight projects. There are 29 active projects in clean transportation. I only have time to cover a handful of them, but there are so many more, and I'll point you to our website and our annual report so you can see all of the amazing projects we have going on within RD&D. The first one I want to talk about is a little less sexy than some of the other ones and some of the other projects we've talked about already this morning. This is a project with UC Riverside CSERT, which is their engineering program, that will evaluate the impact of hydrogen blends in natural gas on the performance and durability of the Cummins L9N 8.9 liter near zero natural gas engine. Cummins set a limit for hydrogen content of about 0.03% by volume. And this is a long-standing limit that was likely based on the typical natural gas composition, meaning typically you would find natural gas in a delivery system with less than 0.03% hydrogen. Since the limit is part of the Cummins specification, using natural gas with higher hydrogen content would void the warranty of the engine. So this proposed work will provide data that could justify the initiation of extensive validation work to increase the hydrogen limit in the Cummins fuel standard. Now, why is this important? We have lots and lots of these Cummins ultra-low NOx engines deployed in fleets, including LA Metro's fleet. But at SoCalGas, we're exploring how can we blend hydrogen into the pipeline, into our delivery product, And one of the key factors limiting the amount of hydrogen we can put into the pipeline is the impact on CNG engines. And so what we want to study here is the impact on the engine, make sure that running more hydrogen through the engine doesn't damage the spark plugs or the seals or any of the other engine components. And then we also want to look at emissions, because that's very important in the LA basin and in the air quality management district. We want to make sure that adding hydrogen doesn't impact the ultra low NOx performance of these engines. And by the way, SoCalGas RD&D supported Cummins Westport in the development of these ultra low NOx CNG engines. So the next project we'll talk about, Tim mentioned this earlier. This is a hydrogen fuel cell yard truck at the Port of Los Angeles. The California Air Resources Board awarded GTI and a number of technology partners to develop and demonstrate 2 fuel cell electric yard trucks at the Port of Los Angeles at a facility operated by TRAPAC for 12 months. Yard trucks are the single largest source of emissions in all classifications of cargo handling equipment. The project is intended to demonstrate to port terminal operators that fuel cell powered zero emission yard trucks is a safe, reliable, and operationally preferable solution to meet the port's Clean Air Action Plan. So the trucks are supported by HTEC's hydrogen fueling system, which provides fuel in a similar manner as diesel is currently provided. So 2 of the hydrogen fuel cell trucks, you can see them in the photo, it's over here, are currently operating at the facility. You can see there's a fueling station here and one of the port operators refueling the truck. The truck was showcased at the 2021 ACT Expo in Long Beach and received over $5 million from the Air Resources Board to help develop this technology. And I will say the preliminary results suggest that this first generation of truck is extremely overbuilt. And so we're looking forward to the second gen, which will be much cheaper because it needs less fuel cell, less battery capacity. It's just over-engineered at this point. So that's one of the major cost savings that you'll see when you talk about learning curve effects, or how do we get the cost of these vehicles down, is as we learn more about the vehicles, we can design them more efficiently. We recently announced that we're working with Ford Motor Company on a demonstration project to reduce commercial fleet emissions by developing an F550 Super Duty hydrogen fuel cell electric truck. This collaboration is part of the U.S. Department of Energy's Super Truck 3 program, which aims to reduce emissions in medium and heavy duty trucks. This is part of our another step towards our Aspire 2045 sustainability goals, which set the standard of replacing 50% of our over-the-road fleet with clean fuel vehicles by 2025, and then operate a 100% zero emission fleet by 2035. So in this project, Ford will provide SoCalGas with an F550 Super Duty truck fitted. I think it's going to be a crane truck, so it's fitted with all the equipment that our standard workers and would use within the fleet, within their day-to-day operations. But it will be operating on hydrogen fuel cell electric technology. With SoCalGas was chosen to evaluate the prototype because of the rigorous demands of utility work and because of our climate and our geographical location. So this truck will actually be out in the field. It'll be on and off road, out there helping to make repairs and install new equipment. We'll also likely install a temporary hydrogen refueling station at our Bakersfield facility, and we're looking to deploy this truck in 2025. And this last project, just to give you a sense of the sort of the breadth of the clean transportation program, looking at the potential for hydrogen ecosystems at airports. So this study provided a high-level assessment of the components required to convert Ontario International Airport into a hydrogen ecosystem to support a zero-emission regional and short-range aviation and transportation. The project analyzed the total energy demand and fuel consumption to support zero-emissions aviation and transportation. We look to address opportunities and challenges for the deployment of electric and hydrogen aircraft and vehicles, and identified associated infrastructure needs to support the growth of zero-emission transportation. This is a really exciting project because of this. The technical advisory committee was just an amazing set of experts from the Department of Energy, the FAA, Air Resources Board, California Energy Commission. We had airports, industry like Airbus, Toyota, ZeroAvia, and then other startups and industry leaders and public agencies. There's a lot of really detailed information about energy usage around airports, but I just wanted to share one of the key takeaways from the study. Preliminary results suggested that converting just 3 types of ground service equipment, these are the vehicles that run around on the tarmac servicing the aircraft, so just converting 3 types of ground service equipment to zero emissions would reduce CO2 emissions by 52% and NOx emissions by 89%. From an RD&D perspective, this is really valuable context because it gives us direction on which pieces of equipment we should work on and focus on decarbonizing right away. So we look forward to working with other technology developers to help convert aircraft tugs, bag tugs, and cargo tractors into fuel cell electric. And like I said, there are many, many more projects within our program. So if you'd like to learn more about the RD&D program, please visit our webpage. You'll find our annual report. It's available in English and Spanish. You can find out about upcoming webinars. You can see our webinar recordings. You can learn about some of our project spotlights, which provide a deeper dive into our most exciting research projects, and RD&D in the news to learn about, see all of our press releases. Also, don't hesitate to reach out to me or my team by email at rddinfo@socalgas.com if you have questions, or if you'd like to sign up for our quarterly newsletter. And with that, I will say thank you for the time, and I look forward to the discussion.
All right. Thank you so much, Matt. That was really great. So much great information today, trying to capture it all and put it into something concise for us. With that, I'd like to, we'll just move into our next poll. All right, hydrogen fuel cell buses have a better mileage range than diesel, hybrid engines, fully electric engines, gasoline engines, compressed natural gas. Most have all of the above and some with fully electric engines. And our next speaker from Foothill Transit, I think, will be able to share with us their conversion over to hydrogen and some of the reasons for doing that. With that, I'd like to invite up Roland Cordero from Foothill Transit to speak on their current project in moving over to hydrogen, the hydrogen fleet. Roland, please.
Hi, good morning. My name is Roland Cordero. I'm the Director of Maintenance and Vehicle Technology at Foothill Transit. And this morning, I'll just share our journey to zero emissions. Foothill Transit, we're located 35 miles east of Los Angeles in the San Gabriel Valley area. We serve 12.6 million riders per year with a mix of local and express routes. Currently, we have a fleet of, used to be 362, and we're down to 359 buses, with almost 10% of battery electric buses. We retired early 3 of our Proterra battery electric buses early this year. Our zero emissions program began in 2010 with 3 short-range en-route charge Proterra 35-foot buses. We added more buses in 2014, 16, 17, and 18. And our latest addition were 2 double-deck battery electric buses manufactured by Alexander Dennis. In California, the California Air Resources Board issued their innovative clean transit regulation in October 2019, requiring transit agencies to transition to 100% zero emission fleet by 2040. The transition starts in phases beginning in 2023, which is next year. 25% of bus purchases should be zero emissions, and that goes up to 50% by 2026 and 100% by 2029. Since our first order of Proterra buses have only a range of 35 miles, it was necessary to install en-route chargers at the Pomona Transit Center, which is located at the middle of the route line 291. Line 291 is 16.1 miles long round trip. And the line was fully electrified in 2014 with the addition of 12 35-foot short-range fast charge battery electric buses manufactured by Proterra. In 2017, we received our first fleet of Proterra extended range buses, which supposedly had a nominal range of 251 miles on a single charge. Our actual findings operating the buses in actual service showed only an average of about 150 miles, 159 miles. In order to operate these buses on line 280, which we had planned to electrify, we needed a way to extend their range. What we came up with was to install a range extender. We built 2 overhead chargers at the Azusa Intermodal Transit Center, located at the beginning of line 280. Line 280 is a 22-mile round trip utilizing 14 extended range buses. We added dwell time to enable the buses to trickle charge, providing the additional battery energy to meet the line's longer bus blocks. There you go. In 2018, we completed our first in-depot charging station at our Arcadia bus yard. This project was in partnership with Southern California Edison and Proterra. Foothills Transit was one of 4 transit agencies selected by Southern California Edison for their Transport Charge Ready pilot program. Edison designed and built and permitted the infrastructure connection from the transformer to the bus yard, while Proterra installed the chargers and overhead structure. As part of the Transport Charge Ready program, Edison gave Foothills Transit a 50% rebate on the chargers, totaling an amount of about $250,000. Operating battery electric buses for the last 11-12 years show that battery electric buses have the proverbial range anxiety due to its limited range. Charging buses takes hours to charge in depot, and dispatchers must be fully aware of what buses are fully charged and ready for deployment. In-route charging infrastructure costs are expensive, and they can cost up to about $700,000 per unit. Maintaining battery electric buses are inexpensive while they're under warranty period. However, maintenance costs can be very costly when technology related parts fail past the warranty period, such as inverters at around $12,000 a piece. In 2018, we hired Burns & McDonnell to prepare a study for a plan to transition to 100% battery electric bus by 2030. The report was issued in 2019 and indicated that it will cost Foothills Transit about $120 million to transition to 100% battery electric fleet. The battery electric buses are a 1.5 to 1 replacement and requires us to increase our fleet size to operate our current service. Consultants provided us with a recommendation for the operations, and for a financial perspective, they recommended that we only charge the buses during off-peak electricity usage, which would lower our overall cost. However, that's not possible since buses have to be repaired, and charging the buses would only allow us to, electrifying our fleet would only allow us to electrify 60% of our bus routes. Over the time it took to do the study, we began to get results from other transit agencies or partners who were using fuel cell technology. And we requested Burns & McDonnell to compare fuel cell technology with battery electric fleet. Why fuel cell? Range of up to 350 miles on a single fill-up for a fuel cell bus. They operate like your CNG or diesel buses without the fear of buses running out of charge while en route. The cost to build fueling infrastructure for over 100 buses costs about $6.6 million. And scaling the fleet size will only require minimal cost by adding another hydrogen tank. The fueling process takes about 10 minutes to fill each bus versus hours to charge an electric bus. California offers several incentive programs to assist in lowering the operating and capital costs of both battery electric bus and hydrogen bus. Low carbon fuel standards, or LCFS, allows agencies to earn credits from operating zero emissions fleet. Other programs include the HVIP, hybrid and zero emissions truck and bus voucher incentive project. There's also a VW mitigation, which offers up to about $400,000 for fuel cell electric bus purchasing. In order for us to move forward with our hydrogen fuel cell program, we had several procurements that was required. We had to issue the following procurements to move forward. We purchased our fuel cell buses through the California State Zero Emissions Vehicle Program. We issued procurement for the design, build, and installation of fuel cell fueling stations. In order for us to move forward with maintaining and repairing our fuel cell buses in our maintenance building, we're required to install hydrogen detection systems and upgrade the ventilation. We also entered into a contract for the operations and maintenance of fuel cell station and provision of liquid hydrogen. We received our first hydrogen bus last month. Additional buses will be delivered beginning mid-September. We have an order of 33 buses with New Flyer, which is the largest order of hydrogen fuel cell bus in North America. Completion of our fueling station. It's currently under construction, is expected to be completed by the end of this year. Program timeline as shown here, November, we had some supply chain issues, especially with the tank delivery. Now it's been extended to December of this year. That concludes my presentation, and I'd be happy to answer any questions you may have.
Thank you so much, Roland. That was a great transition over to really think about the different technologies that are out there and the decision points that are being made in moving forward on these key issues around new and cleaner fuels. It's one of the questions I put out there in each of our dialogues, is really thinking about the role of government within this process and what needs to be done to really help some local agencies figure out the best way to move forward with these difficult decisions, and thinking about what is the right choice in these large investments. So thank you for that. With that, we have time now for discussion and questions. Of course, I always have many questions, but I will open it up first to each of you for any questions to any of our speakers. Well, I'm going to throw it to each of our speakers on this first one. So, and this might be, I don't know if it's too complex or too professorish, but what really are sort of the first steps for communities to think about the implementation or bringing about hydrogen into the area? And how do you foresee sort of the deployment of hydrogen within sort of, maybe the public or, the individual user, as opposed to, just sort of the heavy duty vehicle sector or the more industrial sector, or, those of more the industrial operators?
I can start us off, if you don't mind.
Please.
Yeah, starting hydrogen in a community, captive fleets are a really great way to do that. That's one reason why transit has been at the forefront of zero emission bus and zero emission technology, really in general. Having a captive fleet allows the same people to be looking at the vehicles every day, to get familiar with the technology, and then become advocates to help others as well. So looking at things like transit buses, refuse collection, municipal fleets, a very good way to get into that. Combined use is also excellent, and particularly for the group here today, San Bernardino looking at hydrogen fuel cells for rail, Omnitrans looking at it for buses. That helps to get a common, or have the potential for a common fueling resource in a community. In Southern California and in the Bay Area, it's getting more and more common to have hydrogen resources closer and closer by. As Al serves his market more and more, those will become more and more common, but finding common users in a common area is a great way to look at getting hydrogen started in your community.
Great.
Yeah, and Kim, just following up on that, what's really important here, and I think California has experienced this over the last 10 years, is to get into this, to evaluate this from a complete ecosystem, looking at it from the standpoint of, is there available supply, and how can we supply the molecules? How do we put the technology in for fueling the vehicles, getting the vehicles itself? what kind of support you need for maintenance and services and things of that nature. There's been a variety of experiences over the last 10 years. California has led and has done a great job on adopting fuel cell vehicles, but it's also learned some hard lessons in terms of, is the whole ecosystem ready to supply? And so that's an important step that needs to be considered.
Mhm, mhm. And do you have guidelines for some local, for local areas to figure out how to adapt or adopt hydrogen, or figuring out the whole ecosystem? Is someone doing that type of planning?
I think CARB and the California Energy Commission have done a lot over the last couple of years in terms of preparing documents to help people understand the details that are involved in the process. So those would be the first two, because they have been on the forefront of leading this process. But I think, to answer your question, I think any of us that are in the market will also contribute to those discussions, whether it's molecule supplies or the equipment supplier or the fueling system providers and so forth.
Right. Matthew?
So, yeah, I mean, just to follow up on the initial thought of, how do we get hydrogen into the communities? I think there's a really interesting research opportunity here. Within light duty vehicles, battery electric vehicles, the use case I typically hear from folks on Twitter and LinkedIn and in regular conversation is, well, battery electric vehicles are amazing. I can pull it into my garage. I can charge it overnight using the solar panels that are on the roof of my home. I can commute the 15 miles to my office where my employer is providing free charging in the parking lot. It's great. Why would I look at fuel cells, or why would I consider hydrogen? And I think there's a real opportunity to look at other use cases, and we're ignoring a large portion of the population that doesn't have a garage, maybe doesn't have off-street parking, certainly can't put solar panels on the top of their apartment complex. Maybe they are work in trades or home healthcare where their commute or their trip to work is different every single day. And one day it may be across town, and the next day it may be across the county. So, this is a role that centralized hydrogen fueling for light duty vehicles can really play a role as far as decarbonizing the whole fleet. We don't talk about either or, we talk about yes and. We need battery electric light duty vehicles, but we're also going to need light duty fuel cell electric vehicles for other types of users.
That's great. And Roland, any thoughts on sort of the rollout and the infrastructure needs over at Foothill?
Everything is working out fine for us. The benefit of transforming into a hydrogen fuel cell is you don't need a huge amount of space to lay out your chargers, your overhead charging infrastructure and whatnot. For us, the hydrogen station that we're building has a capability of fueling up to 100 buses. It's costing us $6.6 million, a lot cheaper than buying chargers or building the overhead infrastructure, especially if you're charging in depot using a overhead structure. It costs a lot more. We were able to we're installing a 25,000 gallon hydrogen tank, because it will be a delivered hydrogen from, we have a contract with Messer for 3 years. It's liquid form, and we're installing the whole infrastructure in our existing facility. The study that was concluded, that was done by Burns and McDonnell. In order for us to install charging stations at our Pomona yard, we would have to build an overhead structure and install all the equipment over the parking structure itself. And having really tight spaces, it was just inconceivable to do that for us. So I think hydrogen is a huge space in terms of fuel, even just for private cars. Everybody was talking about infrastructure. How do you build infrastructure for private vehicles? And I was speaking with a gentleman from Chevron the other day, and I said, well, I think it's a lot easier to build infrastructure to fuel private vehicles rather than building charging stations for electric cars, because you have existing gas stations. And basically, it's the same concept. You build it, you install a tank, you deliver hydrogen, you install fueling stations. So you can take some of your existing gas stations actually to turn it into hydrogen fueling stations. Because sometimes you have gas stations that are like within a mile from each other, rather than having to build. How do you build charging stations every mile or every few blocks from each other so people can pull up and charge their vehicles? So.
Great. Thank you very much. We do have a question in the chat, and it sort of follows up on this idea of the delivery of hydrogen. So I've read that the EU has a plan to upgrade natural gas lines. And is that accurate, or any thoughts on the infrastructure needs in the state to deliver hydrogen to a variety of locations? And that's from
As the representative of the gas company, let me take a swing at this so that I'll get my bonus this week. It's an interesting question, and it's a key focus of a lot of research. So in the UK, they are blending hydrogen into limited portions of natural gas infrastructure. At SoCalGas, we're also pursuing research around that. So we have something called the Living Laboratory Project, which is at one of our facilities in Pico Rivera, where we have a simulated pipeline system that we're going to test blending hydrogen. It's an extremely complicated research question, because there are so many different materials, not just the materials the pipes are made out of. They're made out of different types of steel. There are some plastic pipes. There are also seals and valves and regulators and compressors and meters. All of those things have to be tested and verified to make sure that the hydrogen blends don't impact them negatively. And so we're working with utilities across the United States to tackle all of those questions. And then my team looks at, well, what happens to your hot water heater or to your stove as you increase those hydrogen blends, which we also have to kind of verify that everybody's equipment will work on it. And as I mentioned, CNG vehicles, what are the impacts on that? So a lot of really interesting questions around that space. But I'm optimistic, because what we're seeing in the UK, we're seeing this a little bit in Canada as well, is that they're successfully blending hydrogen in with natural gas and delivering that to their customers. Now, if you want to deliver hydrogen to a hydrogen fueling station and you blend it in with natural gas, that really won't work, because when you get to the fueling station, they just want the hydrogen. And our D&D program is demonstrating a process from a company called HyET, which is an electrochemical hydrogen separation and compression system. So it's sort of like a fuel cell. It's a little solid state device. And when a blend of natural gas and hydrogen comes along, it can filter out and purify the hydrogen. It can also compress it to really high pressures without any moving parts. And so we've demonstrated that at our facility in Pico Rivera as well. So that's a potential opportunity for delivering hydrogen through the natural gas pipeline to hydrogen fueling stations. And as I said, we serve 22 million customers in Southern California through 6 million meters. I mean, we have pipes everywhere. So if we want to get hydrogen anywhere, we can do it through our pipes. We are not currently authorized to blend hydrogen into our pipeline. So I'll put that in there for the lawyers. We can't do that right now, but it's definitely an area of interest for the utility.
That's great. Thank you, Matt. Al, did you have anything to add to that? Or?
No, that was a great response by Matt. And as far as Europe is concerned, I think they're exploring all kinds of different ways of moving hydrogen around. Part of that is driven by the density of the populations in certain areas. So this idea of using pipelines is not unusual, and I think that's happening at other locations. Linde has a major pipeline in a couple of different locations around the country, and we're working with various players to discuss the idea of taking hydrogen off those pipelines that are adjacent to the customer and using it for fueling and other applications.
That's great. Thank you.
If I could add to that just a little bit, I mean, the nice thing about hydrogen is that we have a multiplicity of options rather than a lack of options and a multiplicity of uses. I mean, for hydrogen and fuel cells in vehicles, we need very pure hydrogen. And that's an issue we have to talk about when we talk about pipeline transport, but there's so many other uses. for hydrogen, including combustion hydrogen, which is getting attention again. That's what they're doing at the Intermountain Power Project with those Mitsubishi turbines up there, and Cummins is working on as well. So, the methods of transport and distribution, we have to take on a more nuanced look at how we produce, transport, and use energy. It's not going to be a silver bullet solution, as so many people want to find. And I think that it's good, because if we tried to hardwire 2050 today and do everything through the grid, we'd get it wrong in a lot of ways. The way these sources and loads are going to move and change as we progress through these next couple of decades of decarbonization will be highly dynamic. And the nice thing about hydrogen is that you have that flexibility of transport modes as well as production and usage modes. It's going to be a lot more flexible. The grid's going to do a heavy job over the next couple of decades. It's a lot of work that the grid's going to have to do, but it can't do it all. And in fact, there's some places where hydrogen can do it a lot more safely. So pipelines supplement that, but we're still going to see liquid and gas transport as well as some of these other chemical carriers as well.
It's great. Yeah, lots of implications for future development and thinking about innovation, the role of government in that, as well as some geopolitics there, and thinking about Europe and their issue with gas lines now. And maybe hydrogen, what role that would play there. We have a question in the chat, but we'll go to our hand up. Michael from Glendora.
Great, thank you, Kimberly. It was talked about with the Burns-McDonnell report. Was there an analysis done on battery versus the hydrogen fuel cells? Because batteries are about 8 years or so. You've got the life of the battery, then you have to do something with them, either put them in a wall for storage for something else, or try to find one of the two folks or companies in the United States that will recycle them. And then also fuel cells, they also have their issues as well. They kind of go bad after a while, need some maintenance and loving care. Is there a nexus there of what that cost analysis is between trying to find the recycling of the batteries after 8 years and the cost to maintain the fuel cell technology?
Yeah, great question. Thank you very much. So Doran and I went to Ballard last week, visited their plant over in Vancouver. Battery electric bus batteries, they only have up to about 70% life. Once you reach the 70% life, that battery is ready to die out. One of the things that is in discussion and still trying to figure out is how do you recycle those batteries? Obviously, there are rare earth metals that are included in those batteries. Trying to use a battery that's about to die off and use it as a source of recharging, as a battery energy source to charge your buses. I don't think that's a very applicable solution. In terms of fuel cell is a battery electric bus. Hydrogen bus is basically an electric bus. It operates with a fuel cell stack. You fill up the bus with hydrogen. The hydrogen goes through the fuel cell stack and creates electricity to charge your buses, your batteries. So you have a smaller battery pack on a fuel cell bus, usually about 95 kilowatts or 100 kilowatts, right, Tim? Versus 440. Now we're at about over 600 kilowatts on a battery electric bus that could supposedly get a range of about 250 miles. So it was interesting during our visit at Ballard last week. They explain how there are so many elements on a fuel cell stack that could be recycled. So basically what they're doing at Ballard is when you send your fuel cell stack, they would take the MAEs or the fuel cell liners itself. They can pull out certain elements out of that stack and replace it with another set of fuel cell stacks. I mean, I don't know if I'm making sense with you. I'm trying to be as technical as I can with what knowledge I got from our visit last week. But actually, the process of refurbishing a fuel cell is a lot more efficient than trying to refurbish or get recycled materials out of a high energy battery from a battery electric bus. There are elements that we can send our fuel cell to Ballard. They can replace the stacks and send it back to us. And a lot of those components are recyclable. They can pull out all the titanium and all the different rare earth metals. I know, Tim, if you want to expand on that a little bit, because you're a little bit more of an engineer than I am.
But is there a statistic, though, of how often you have to basically overhaul the fuel cell?
Yes. I think they have, if I'm not mistaken, was that 4 to 5 year life, Tim?
Well, we should be about 20 to 30,000
20 years?
hours.
Okay.
So we should be hitting the 6-year lifetime, which is right around what we expect from a combustion engine. So we expect a midlife rebuild of the fuel cell module. So over the 12-year life of a fuel cell bus, the stack will need refurbishment at about halfway. And when that happens, the module comes out, the stack comes out and gets replaced. That stack goes back to Vancouver. And, to be honest, the comparison between fuel cells and batteries isn't really fair because fuel cells have a natural advantage. I mean, we are a sandwich of plates and all we do is cut the bands and everything separates out. The carbon plates we use, we wash, inspect, and reuse those about 6 times. And we'll recover about 95 to 97% of the platinum out of those like cellophane like membranes. So, and then as Roland was saying, a lot of the other pieces and parts are steel, and there's very common steel recycling processes for that. So our recycling story is quite good. Our embedded energy story is quite good, and the cost is quite good too. We're about 25% of the cost for a rebuild versus a new purchase. So we feel pretty good about the midlife characteristics as well.
Thank you.
Our next question in the chat, it says to all presenters, it appears that transit operations may be well positioned to contribute substantially to the development and expansion of use of hydrogen fuel cell in the transportation sector. Has any consideration been given to hydrogen fuel stations that would service transit buses and HD or MD trucks, so heavy duty or medium duty trucks?
I'll start off on this one. Oh, I saw Al was just taking a breath in. I'll be quick. We are looking at this. I mean, and Roland can comment on this too. Some transit agencies would prefer to have their fueling assets contained and control over those. Some are also providing public fueling stations more on the car side, but the trucks are really going to start seeing some public fueling stations. And I think there's real work being done on public heavy duty fueling stations, HDMD, heavy duty, medium duty, delivery trucks up to the big class 8s. I think NextEra, a big renewable energy project developer, has partnered with Daimler for a series of hydrogen fuel truck stops along the southern edge of the US. But there's lots of activity all over the place on this, especially as you see drayage trucks coming out of the port of LA and Long Beach. You'll need fueling resources for those. And I think some of those will be shared with transit agencies, and particularly outside of the state of California. Having that fueling resource nearby can help a lot of neighbors. So yeah, that's in a lot of discussions right now.
Over at Federal Transit, as I mentioned earlier, we're in the process of building our hydrogen fueling stations. One of the concepts of our procurement, and we're still looking into this, is to provide public access. Same thing with our compressed natural gas station. We partnered with Clean Energy and gave him a use of a part of our property to install a public access compressed natural gas fueling station. And they've had success with that program. They have a lot of heavy equipment, trash trucks. Some school buses that come in and use that public access. We're still looking at the possibility of building a public access hydrogen station within the compressed natural gas. The thing that we're looking at is there really a market right now? Is there a need for that? But if there is, we will continue to move forward with that concept.
Any other thoughts on that piece? I wanted to ask each of you, kind of following up, again, I'm a public policy professor, but why do you think hydrogen's been around for so long, right? Why do you think it's been so slow to really roll out or be part of the larger conversation around alternative fuels and sort of looking at the future? Because it seems there's so much that needs to be done to really bring it into the infrastructure, but it has so many advantages in some ways that I've heard today. So what do you think that piece is of why hydrogen has been, I don't know, in second place or been a little bit behind? Rafi was speaking yesterday about, he was trying to do a little bit of research and was really hard to even find a lot of information about hydrogen in a simple kind of, initial kind of Google search. So why do you think that is? The slow rollout?
Yeah, Kim, I mean, you have to acknowledge the fact that for the last 100 years, the petrochemical industry has had a very strong advantage, okay? They have the stations in place, they have the automobile companies making the cars, they have the refineries that are large scale, very large scale. And so they clearly had an advantage there that's very difficult to overcome, okay? And it's now that we are really recognizing that the one thing they can't do is address the issue of climate change, okay? And we have to come up with a different solution. So we are now embarking on this process of overcoming that 100-year advantage, okay, that they've had in terms of putting the scale of production in place, putting the distribution systems in place, putting the dispensing facilities in place to fuel the individual vehicles and so forth. And, I think if anybody drives down the 405 and sees the refinery capacity that's down there, that took years to develop, okay? And it's a massive amount of capital to build that. And if you go to Texas, it's probably 5 or 10 times bigger, okay? And so, recognizing that we have to address this issue of climate change, now we have to put in all the infrastructure and we have to get everything coming together. We have to have demand and supply coming together. We've already experienced situations where there's been demand and no supply, and that's a really difficult situation to manage. So that's one of the issues that I see is we are embarking on this. This is, to whoever made the comment, this is not going to be a fast solution. This is going to take years. Southern California Gas was mentioning that they have a plan that goes out to 2050, I think. And that's exactly right. I mean, we have to think in terms of decades to get this transition underway, but we have to start today.
Yeah, it's an interesting piece. And it's one of the things, Matt, sorry, just to kind of respond to that, the need in these smaller communities. I mean, if we look at electric, almost anybody can almost just, if you have a home, apartment dwellers, of course, are different, can come and you can buy your car and you can plug it into your house, more or less. This infrastructure that needs to be built out for the hydrogen. Sorry, Matt.
Yeah. I mean, I think that hydrogen really makes the most sense when you're talking about 100% decarbonization, because the scale of what's proposed is so awesome. You're talking about decarbonizing our energy system is really replacing our energy system if you're going to use hydrogen. And hydrogen allows you to do the 100% solution. I don't think we've ever had the courage to say that we're going to go 100% carbon free until probably about 5 to 10 years ago at most, right? I joined Ballard back in 2000. There was a lot of hype about hydrogen. Our stock prices were soaring. The big automotive companies were jumping in. And the economics weren't there to be compelling without a whole lot of investment. And there was no zero carbon neutrality mandates that existed. I credit hydrogen's real rise now to Elon Musk. The success of Tesla, the success of EVs really emboldened policymakers to look for 100% decarbonization. And when you go to 100% decarbonization, you really have to look at hydrogen. And I think that's what's made all the difference, was the fact that the realization that we have no choice but to go to a fully decarbonized energy system. And to do that, we need hydrogen. We need to make the investments. And once you do, it becomes more economic, but you have that whole energy system that does need that revamp. And on the grid side, it has to be done as well. Even brother Elon has admitted if we fully electrified all the transportation and put it on the grid, we'd have to double the electricity that we're serving right now. And we know that not only would we have to rebuild what we already have, we'd have to do it differently. We'd have to do it safely, with undergrounding, with more expensive approaches. So this is not free just doing it with a battery grid approach. Once you get past something like 10%, you've got to start making real important grid investments. And like I said, wiring for 2050 in 2022 may not be the best option. So all of these things come into focus when you look at a complete decarbonization of your energy system. And that's why hydrogen is really resonating more and more every day now.
Mm-hmm.
Yeah, I think Tim's cost curve plot was really compelling. That basically, if you want to do an electric vehicle, it's super cheap to do it for the first vehicle, for the second vehicle, for the third vehicle. When you get to 100 vehicles, then you start to see the impacts. And it's the exact opposite for hydrogen. The first vehicle you put on, you need a hydrogen fueling station, you need hydrogen production, you need delivery. It's super expensive. But as you deploy more vehicles, those costs come down dramatically because of the scalability of the technology. And so that's one reason. If one way Tesla was so successful was they could sell one vehicle, and the customer took ownership of the vehicle, plugged it into the wall, and that was it. They were up and running. But they say the grid is, it's great if one person in your neighborhood has an electric vehicle. If more than one person has it, then you start to see the problems. So
Yeah.
I think
Yeah,
that's
It's
one of
like
the
cable
key things.
internet.
In terms
There
of,
was a lot of, yes, sorry, Roland.
in terms of public transportation, there's one item I think that's kind of, preventing other transit agencies to transition to a hydrogen fuel cell. Back in the days when battery electric buses came out into the market, hydrogen buses came out in the market as well, but hydrogen buses were a lot more expensive than battery electric bus. The prices come down to almost in parity now. They're pretty close. The problem with hydrogen bus is that the availability of hydrogen, how close can you get hydrogen? I mean, being delivered to your facility. I mean, look at AC Transit in Oakland. They're getting their hydrogen from Ontario, California, being delivered from Ontario all the way to Oakland. AC Transit is getting their hydrogen from up in Northern California. For us, luckily, our contract with Messer through Clean Energy, it's down Ontario. But the problem is the price of hydrogen, not only the availability, but the price. We have a 3-year contract with Clean Energy for the provision of hydrogen at $9.12 per kilogram, right? But if you convert that into cost per mile, comparing it to battery electric, that's twice as much as what we're paying for electricity to charge our battery electric buses. Lately, since our buses are full, a complete set of 33 fuel cell buses will be delivered by October and November, and that's prior to the full completion of our fueling infrastructure at our Pomona yard. We're looking at ways to figure out how we can temporarily fuel those hydrogen buses. And we're getting prices all over the place, from $13.50 per kilogram to $18.50 to $20 per kilogram. It's crazy. That's not sustainable. I think Doran would not be amiable to fueling hydrogen buses at that cost per kilogram. That's crazy. There has to be a way where we're going to have to develop a fuel hydrogen hub in California, just like what they're doing in Georgia, and provide hydrogen at a sustainable cost. There's no way that, the technology is there, but, transit agency, you would see a high scaling of fuel cell buses in the market until we come up with a sustainable price. It's crazy.
Roland, were you getting a preferential rate for charging from Edison, or were you paying retail?
Right. No, we're not paying retail. We started a partnership with Southern California Edison 10, 11 years ago when we started our zero emissions program. And we worked with them all throughout the years, and we've had several discussions on how the utility can help the transit industry. So one of the things that they did at first was to waive the demand charges for 3 years. After that waiving of the demand charges, they came up with a more reasonable electric vehicle rate. Now we're at EV8 rate. There's several different strategies or different levels of EV8 rate charges, depends on how much kilowatts you're utilizing. So for us, we're being charged an EV8 rate, which is comparable to what we're paying Edison when the demand charges were waived. The EV8 rate also eliminates demand charges over the next 10 years, but it will slowly, gradually come back in. So the rates are reasonable for us. But
yeah, but so Kimberly, from a policy standpoint, I think it's important to note, and a lot of people don't live in the utility industry the way I do, and we do at SoCalGas and SoCal Edison. Rate setting is a policy mechanism, right? When you set preferential electricity rates, you are setting a public policy, and that comes through the Public Utilities Commission. And so when you say demand charges, we're going to waive demand charges, those charges, those expenses, those costs don't go away. They just go to another customer, right? They went to everybody else. And that's fine. I mean, that's a valid public policy mechanism, right? We want to promote zero emission vehicles. But again, that's a public policy that was supporting battery electric buses or electric vehicle charging. It's one of the mechanisms. And then low carbon fuel standard, I think, is something is a different public policy mechanism that can support hydrogen and other clean fuels. But I think that's important to know. I mean, one of the things we're seeing with hydrogen production, and particularly green hydrogen production, is the number one cost component is the cost of electricity. Running your electrolyzer, if you can get cheaper electricity, if you can get 2 to 3 cents per kilowatt hour electricity, you can get really affordable hydrogen, and you can't get that on the grid. But you know, we talked a little bit about Angeles Link, and what we're seeing a lot of solar developers is co-locating hydrogen production with solar production, because at the point of production, we are seeing solar plants that produce 2 to 3 cents per kilowatt hour electricity. And so, and they can't even get 2 to 3 cents for it when it goes onto the grid, right? Because at noon, nobody wants electricity. There's already a flood of solar on there. So we're starting to see some developers who are looking at hydrogen production as a way of using their super cheap electricity. But you have to, you can't go on the grid. The grid costs a lot of money.
And to speak to that, I mean, an easy way to think about hydrogen costs of production anyways, and Al might hate me for saying this, but an electrolyzer, if you're talking about electrolyzer takes about 50 kilowatt hours to make a kilogram of hydrogen. Kilogram of hydrogen is about comparable to a gallon of diesel. The vehicles are more efficient, but forget about that. So to get a kilogram, you need about 50 kilowatt hours. So if you're paying 10 cents a kilowatt hour, that's about $5 a kilogram. So some of these new incentives coming down the pipe. Now, on top of that, you add in the cost of liquefaction if you're liquefying it. And if you're going long distances, you should. The cost of transportation, of course, and the cost of all the equipment that gets baked into that. So you're not going to be buying $5 a kilogram for electrolyzed hydrogen today. If you own your electrolyzer, you might think about that math, but it helps you to understand what these incentives might mean. The federal incentive that just came through in the Inflation Reduction Act is up to $3 a kilogram for zero carbon hydrogen at the point of production. That's really good. You also, if you are electrolyzing it, the production tax credit for electricity can be kicked in, which can be up to 2.5 cents a kilowatt hour. And as Matt was saying, for very large installations, you may see solar or wind production at below 3 cents a kilowatt hour. Now, this is getting compelling, right? And some of these more distant production resources are difficult to put in brand new transmission lines for, and may make more sense and be more economical to harvest that new renewable electricity with hydrogen. And we know we're going to need 4 to 5 times at least the amount of renewable electricity generation that we have right now to serve all of these decarbonizing sectors. So we've got to put in a lot more wind and solar, and turning that into hydrogen can be a much more economical and safer way in a lot of applications.
Al, did you have anything you wanted to add to that? Or
No, both of these discussions were spot on, and I want to fully support the comments they had. And the other thing is that we are in the early development of large scale hydrogen supply as a fuel, and it's no different than Tesla selling $100,000 little sports cars when they first came out, and now they're being more competitive. You know, prices will be coming down on fuel. So Roland, I commend you for being on the leading edge, and I understand the pain that you're sharing. But on the other hand, I think your future is going to be a lot brighter when it comes to fuel costs, and it's just going to take a little time. There are projects being developed across the West right now that are going to contribute to much lower cost hydrogen over the next 5 years.
Great. Doran, did you want to add anything? I mean, I think scale definitely has something to add into this, and sort of the economies of scale, and how we are in this time where maybe it's very fortunate to live in a time of great change, and Moore's law, and it's moving faster, I think, than even that doubling in 7 years. But this idea of just this great amount of change and what it means for our society, but it's also a time of, unknowns. And it's difficult to ascertain all of the pieces that are out there and how much it's going to be. But as we note in the past, scale does come into it, the economies, and things do get more affordable, especially if Omnitrans, many of our Omnitrans friends are on the line today, start to adopt hydrogen as well. Doran, I'm sorry I cut a bit of your thunder. And I don't know if Aaron wants to add in anything after that.
Sure. First of all, thank you to all the presenters. That was very overwhelmingly educational and informative. No, I mean, we just received a grant. We were just successful in a grant for our first 4 hydrogen buses, and we'll be partnering with Lindy on the fueling, as well as with San Bernardino Valley College on an apprenticeship program for our technicians. So we're very excited about all of that. And what we know for sure is, we need partners because we don't have the real estate to build this infrastructure, because of the locations of our, size constraints and location of our facilities. And, we have just 4 battery electric buses right now that that we have in service. So, we know all the limitations that come with those. And so we're testing, we're planning to test both before we, and relying on all of Roland's, Roland's input and experience and all of our other partners. But, we know that we'll end up with a mixed fleet, and we're not sure exactly what that will look like, but, the information is helpful as we start to get into this. So, but partners, we will need partners, and we know, we have such a, so much freight and trucking in this region too. So, I'm really looking forward to the possibility of a hydrogen hub somewhere that is, feasible. We're just going to have to look at doing things differently. I mean, normally we would say, oh, we have to have our own fueling station, but I don't know that that's going to be the case for us in the future. So.
Thank you very much, Aaron, for that.
Thank you. Did you figure out your audio, Doran?
Yeah, I don't know. Tell me, did I?
There we
do it?
are.
No, yes, there you are.
Every time I change platforms, everything gets redone. It's crazy. So, Doran Barnes, Chief Executive Officer at Foothill Transit, and this has been a great discussion. I do think as an operator, and I, Aaron and I partner constantly on all kinds of projects and learn from each other and share. And I think that's really one of the great things that happens in the transit space, not only in terms of what's happening in transit, but also hopefully taking those lessons learned and applying them to other sectors. Roland really hit it for us, and Al, I'm counting on you on those lower costs, because out of the gate, the cost for hydrogen is going to be double what it is for compressed natural gas. And we absolutely believe in the environment and doing things that environmentally make sense. At the end of the day, we've got to balance our budgets, and those costs for us have to come down for this to be a viable fuel. So we'll see. I do think we're at that, I agree with the assessment that we're at this very early stage, and there's a lot to be learned, a lot to be developed. Ultimately, those economic models, like I say, they've got to fall closer in line in the long run to have it make sense. And I think, we're willing to take the risk in the short run, but as we look to future bus buys, kind of taking bigger and bigger leaps on the costs coming down. So looking to everybody bring those costs down.
Thank you, Doran. Rafi, did you have a quick question? We have just a few minutes here.
Yeah, basically I have one just informative question and another one for us. So I remember we mentioned about hydrogen fuel used in vehicles in 3 forms. So one was combustion, fuel cells, and something else. So if we can touch bases on that and the color issue that was discussed in the chat box. And the second question would be, so you guys, what you're expecting as a workforce development from universities, colleges, like how we can embed this sort of demand supply into the workforce development? Like I believe you need people to maintain these this mobility system, to get hydrogen, to process hydrogen. So if you just can touch bases on that too, that would be great. And thank you.
Thank you.
So Rafi, I'm not sure about, you mentioned fuel cell and internal combustion as far as the power to the vehicle. I'm not sure if there's another format to that other than maybe a blended arrangement. There are companies that are working at blending diesel and hydrogen together, okay, or natural gas and hydrogen together for combustion. The third thing that is being worked on, or one of the things that is being worked on specifically by Daimler, is looking at liquid hydrogen on board. We see that as especially for Class 8 vehicles and other large vehicles, we see using liquid hydrogen as beneficial because you have a higher density of fuel on board, and that will take the vehicle a longer distance. So for Class 8 vehicles or for mining applications, maybe even for rail or marine, having liquid on board might very well be the great solution. You have to, there are challenges associated with that, so I don't want to suggest that it's a minor change. We do have to think about safety in terms of how to manage that product and so forth, but progress is being made, and we think that is that's a bright future. It also eliminates some of the high valued fueling systems that you have out there now for 350 bar or for 700 bar. And so that's going to be another way of bringing down the cost of the solution over time.
I might have confused some of that as well. So it talked about using fuel cells or using combustion, but there's different ways of moving the molecule around as well. The thing about hydrogen is very light. So to get a lot of it, you need to either pack it down really tightly, which is where liquid becomes very appealing and really has about the highest volumetric density that you can get. Competing with that are people looking at things like ammonia or methanol, which are interesting because they are fairly dense energy carriers and they can travel with the liquid at close to room temperature, but they've got other problems. Ammonia has some real toxicity concerns that you have to deal with. It's another level of conversion that you're going to have to put energy into, and more equipment on either side that you'll have to pay for and have have your O&M expenses for as well. So, there are people that are looking at that, especially for very large bulk transport of hydrogen in ocean going containers and such. But we're still looking towards really liquid hydrogen as being in the near and medium term, and maybe even in the long term, the preferred source with compressed hydrogen when you've got local production. So, and regarding the colors, really carbon intensity, California's using it, the federal government's using it. You can use it for any fuel. It doesn't matter. It's an assessment of how much carbon per kilowatt hour you're actually getting, and it's most accurate. The color thing really is being used by critics of hydrogen to draw attention to the sources that hydrogen is coming from, which is not done on the electrical side, right? We don't talk about, especially outside of California, the sources that electricity is coming from. We need to talk about all of our electrical sources, all of our hydrogen sources, all of our energy sources in the same conversation. The color thing just makes it confusing. And so by and large, I think the industry is getting away from it.
Great. Thank you. I think that's great. And we do, as building off of Rafi's second question and thinking about workforce development, but also the role and how we can assist in the rollout, or how universities have their piece within this. And we have, of course, our friends at UCR and CSERT and a lot of their research scientists that are working on these key issues, but also the social science part and thinking about the society and the equity issues that are coming about as our systems change, as we have these new innovations, and what it means, and how do we make sure that it's brought out to everyone in the community and not just limited to those who can really afford it or really pay. How do we make sure that it's available and the options are there for many folks?
Yeah,
Some
good.
education,
Sorry.
Sorry, some education shout outs, Sunline, West Coast Center of Excellence, they're building up to train technicians. Rio Hondo College has some great fuel cell programs. AC Transit also has a great training system. We're making our second generation of bus trainer module system with augmented reality and all kinds of stuff. We're very much looking at workforce development, and a lot of the funding programs require it. So there's work
Yeah,
happening.
actually, that's the thing I like to stress is especially the Inflation Reduction Act that was just passed. That has a component in there that is really advocating for education, apprenticeship programs and so forth. And so that's something that should seriously be investigated by the academic communities in California and actually across the country, because that's going to be an important factor.
All right.
Cal State LA has had they have a hydrogen research center. I think they've had it for the last 10 years. In fact, we fueled our first hydrogen bus at the Cal State LA campus. We're trying to develop a training of somewhat of a training facility at our Pomona, possibly with partnership with Ballard. This will not only provide training for our technicians, but have it available to everyone in the transit industry. It's just plans right now. Hopefully, I'm hoping that we can put something together.
All right, well, thank you all. I truly appreciate your time and your knowledge. I feel like we've only touched the surface with this conversation in many ways. And so thinking about next year's dialogues, how we can continue with this conversation in particular, and dig a bit deeper. I've learned a lot. I think I want to do more research, find out more about hydrogen and how it's working, to get a better understanding of everything that's happened, and where we're going with this. So again, I'd like to thank you. I would like to also just make a shout out for Caltrans District 8 that will be hosting a innovation fair on their campus in downtown San Bernardino on, let me make sure I get the date right, on October 25th from 10 a.m. to 2 p.m. And it'd be a great place to continue part of this conversation around hydrogen at Caltrans District 8. So with that, no further sort of comments or questions as we're out of time. Again, thank you so much for joining us today, and we hope to see you at our next dialogue in October, where we begin to think about the change in aviation in the Inland Empire and how our two airports are really moving forward, as we also heard how hydrogen is going to be impacting that as well. So thank you very much, and have a great rest of your day.
Thanks, Kim.
Thanks, everyone. It's been fun.
Bye-bye.
Thomas.